Good morning to everyone. Myself is Devi, Assistant Professor, Department of Artificial Intelligence and Data Science. I am going to teach the subject of data structures using C++. Today we are going to discuss about the topic minimum spanning tree, and then we are going to see Kruskal'S algorithm. We will see what is minimum spanning tree. A minimum spanning tree is a subset of edges of connected, undirected, weighted graph that connects all the vertices without forming cycle and with the minimum possible total edge weight. The minimum spanning tree is a tree that includes all the vertices of the graph among all possible spanning trees. The one with the minimum total edge weight is called minimum spanning tree. There are two algorithms, Prim's algorithm and Kruskal'S algorithm. We will see the Kruskal'S algorithm. The second grading strategy is repeatedly to select the edge in one of the smallest weight and accept an edge if it does not cause a cycle. The steps involved in Kruskal'S algorithm: initially there are a set of vertices. You have to construct a tree with a set of vertices as a single node. Adding an edge merges two trees in one. When algorithm terminates, there is only one tree, and this is the minimum spanning tree. The algorithm terminates when enough edges are accepted. The steps involved in Kruskal'S algorithm is sort all edges in increasing order of weight. Second step is initialize disjoint set for all vertices. Select the minimum weight edges. Fourth is check whether it forms a cycle using find operation. Fifth one is if no cycle occurs, include the edge in MST. Sixth, perform union operation to merge the set. Seventh step is repeat until the tree contains V minus 1 edges are selected. To this example, it contains V1 to V7 vertices, and each and every vertices, the edges of each and every vertices have the weighted. So this is the undirected weighted graph. We are taken undirected weighted graph as an example. Each and every edge contains the cast or distance. So we have created a table with the help of the given graph, and we are about to construct a tree. We have arranged the edges in ascending order, that is from V1 to V4 there is an edge and its weight is 1. Similarly, V6 to V7 there is an edge and its weight is 1. Similarly, all the vertices edges are arranged in ascending order. Now we are going to apply the Kruskal'S algorithm here. Initially, the tree there should be n vertices, that the graph that n vertices, that is V1 to V7. Each and every tree should be a have single node, that is V1, V2, V3, V4, V5, V6, V7. So based upon the weight ascending order, we are going to include the edges in the tree. First one V1 to V4, the weight is 1. So include a edge from V1 to V4 and include the weight 1. Edges V6 to V7. So while including a edge in the tree, we must consider the three things: that it should be a minimum value and it should not create any cycle. So next we are since no edges is there, we have included only one, so no cycle is there and the edge value is also minimum. And next one is V6 to V7. We can include V6 to V7 where where while including V6 to V7 no cycle is created and the value of the edge is minimum, so we can include it. V1 to V2, the edge weight is 2, so we can also include it. While including the edge V1 to V2 no cycle is created there, so it can be accepted. Next, V3 to V4, we can include the edge V3 to V4 with the weight of 2. While including this edge no cycle is created, so this edge can be accepted. And next is V2 to V4. So while including V2 to V4, what happens, and cycle is created, that is V1 to V4, V4 to V3, V4 v3 to v1. So a cycle is created, so this edge should be rejected. So since the cycle is created here, it should be rejected. Next edge, v1 to v3. So v1 to v3. So when you include this v1 to v3 also, it will create a cycle, so we have to reject this edge. Next, v4 to v7. v4 to v7. So when you include this edge v1, v4 to v7, 4 to v7, no cycle is created here, so this edge can be accepted. Next, v3 to v6. So when you include this v3 to v6 edge, the cycle will be created, so it should be rejected. Next, v5 to v7 with a weight of 6. When you include this edge, no cycle is created, so this can be accepted. Next, v3 to v6 with a weight of 5. So this can be rejected. While including this, it will be create a cycle, so it should be rejected. Next, v5 to v7. When you include this edge with a weight of 6, it won't create any cycle, so this can be accepted. So this is how a minimum spanning tree is created. A resultant, there will be a tree constructed with the help of this one, which is a minimum spanning tree. That is, the tree should contain all the vertices, it should cover all the edges, and no cycle is created here. So this, the resultant graph, is known as minimum spanning tree with a weight, with a total cost of 16. That is 2 plus all the values of the edges will be added here to find the minimum cost. That is cost of the minimum spanning tree, that is 2 plus 1 plus 2 plus 4 plus 1 plus 6, which is equal to 16. So the cost of this minimum spanning tree is 16. This is all about the minimum spanning tree. We will see the next topic in the next section. Thank you.